Okay, so let's kind of put this stuff into practice here. You're going to be practicing this with a lot of charts and looking at both information given to you about the number of protons, electrons, and neutrons, and writing nuclear symbols, or you'll be deriving information from your nuclear symbols. So let's put this into practice here. Let's look at this one. We have Ag, which is silver, and it's telling us we have a mass number of 108, and we have an atomic number of 47. So let's see if we can figure out the charge on the atom, the number of protons, electrons, and neutrons from taking the information off of the nuclear symbol. So number of protons is always easy because it's whatever the atomic number for that element is. So here we have silver. Atomic number for silver is 47. So that's how many protons that we have. We have 47. Number of electrons and neutrons, we're going to have to put in a little work to get this. So let's do neutrons first, just because we're working on the same side here. So remember, to get the number of neutrons, we take the mass number, which is the number of all of the particles in the nucleus, and we're going to minus it from the 47, because if 108 represents all the things inside the nucleus, and out of the 108 things, 47 of them are protons, well, then that would mean the leftover would have to be the neutrons, right? So we're going to take the number of the mass number here, and we are going to subtract it from the number of protons. So when we do that, 108 minus 47, it's going to give us 29. Okay, so again, you take the mass number and you minus it from the number of protons. Oops, I'm sorry, guys, it's not 29. It's 108 minus 47, so it's 61. So we have 61 neutrons in the atom, which should make sense because remember, again, the mass number is the number of total particles that are housed in the nucleus. So that's the total number of protons and the total number of neutrons, which will give you the mass number. So 47 of them were protons. We subtracted to get the number of neutrons. All right, so in this nuclear symbol here, we have no charge written. So we assume that it is a neutral atom. It has zero charge. Whenever something has a zero charge, that means it has the same number of protons that it does electrons, because the positive and negative charges cancel each other out. So if there are 47 plus charges, that means that this atom must have 47 negative charges. So we have a zero charge. Okay, so we got all of that information by just looking at the nuclear symbol. So let's try this one over here. We have Ca, which is calcium. It's got a mass number of 41, atomic number of 20, and then we have that +2 charge in the upper right-hand corner. So we've got a +2 charge here. All right, so, number of protons, well, that is, again, the same number as the atomic number. So calcium has 20 protons, okay? So we can figure out the neutrons because, again, that mass number there tells us that there are 41 subatomic particles in the nucleus. We know that the nucleus is only made up of protons and neutrons. So if 20 of them are protons, that would mean the remaining of the 41 would have to be the neutrons. So we have 21 neutrons. And then we've got a +2 charge. Well, it's a +2 charge. So what does that mean? That means we've got more protons than we do electrons because of that positive charge. So we can easily figure that out. That means that this ion here, it's in a bond. We did some type of chemical bond, so it's going to lose 2 electrons because that plus means 2 of the negative charges went away. So we lost 2 electrons. That means that there are 2 more protons than there are electrons. So there are going to be, if calcium has 20 protons and 20 electrons on a neutral atom, but we lost 2, that means there is only 18 electrons. Okay? Again, if you remember, charge is equal to the number of protons minus the number of electrons. So the other way you can use it is you could just use your algebra skills. You've got +2 for the charge. You got +2, 20 here. So we can solve for E. We're going to be subtracting 20, basically. Or I'm sorry, this is a plus. We're going to be subtracting 20 from both sides. So E is equal to -18. That negative is because you're dealing with electrons. They're negatively charged. So there's 18 of them. That's the other way you could solve that.